The next set of identities we're going to look at, or formulas, is going to be the power reducing formulas. What these allow us to do is to go from a trigonometric function that's to the second power to one that's to the first power by kind of swapping out a power for a double angle. We get that the sine squared of theta is equal to 1 minus the cosine of 2 theta divided by 2. Again, this particular, when we look at the beginning, we have a sine that's raised to the second power is being replaced by a cosine that's to the first power, albeit of the double angle 2 theta. The cosine of 2 theta is equal to 1 plus cosine of 2 theta divided by 2. And the tangent squared of theta is equal to 1 minus cosine 2 theta divided by 1 plus cosine 2 theta. In the next example, we're asked to write an equivalent expression for the cosine to the fourth of x that does not contain trigonometric functions of a power greater than 1. Well, one of the ways we can accomplish this, if we think of the cosine of 4x, we can write that as the cosine squared of x times the cosine squared of x. And the reason for this is it's cosine squared of x. That's exactly the formula we have from above. Cosine squared of x, or in theta in this case, is going to be 1 plus the cosine of twice the angle divided by 2. So this is going to be 1 plus the cosine of 2x divided by 2. And this is also going to be 1 plus the cosine of 2x divided by 2. One of the things that I think I'm going to do here as I multiply this out, the denominator is going to be 2 times 2, which is 4. So I'm going to kind of go ahead and just bring that factor of 1/4 out in front. And then I'm just going to multiply the 1 over cosine of 2x times the 1 plus cosine of 2x. This is a binomial times a binomial, so you have to use the general distributive property. Good old school FOIL, if you want to call it that. First, outer, inner, last. You should get the following. This is going to be 1 plus, we're going to have 2 cosine of 2x will be the middle term. And then the last term will be plus cosine squared of 2x. And we very nearly answered the question. The only problem is that we're supposed to write the expression using trigonometric functions with a power that's not greater than 1. And when we distributed this out, notice what we have right now. We have a cosine raised to the second power. We can get rid of that by using that power reducing formula one more time. We have 1/4 times 1 plus, this is 2 cosine of 2x plus, and now let's pay attention to the form that's happening here. When we have the cosine squared of some angle, okay, let's say that this angle is theta, we get 1 plus the cosine of double that angle divided by 2. So when I come down here, if I want to replace the cosine squared of 2x, it's going to be 1 plus the cosine of twice 2x, which should be 4x, all divided by 2. And now we've essentially done it. All of these functions are raised to the first power. And let's just kind of go ahead and clean this up a little bit. I can distribute the 1/4 through. This is going to be a 1/4 plus 2 times a fourth will be a half. The cosine of 2x. This is going to be a 1/4 times this term, which will be plus a 1 plus cosine of 4x, all divided by 2 times 4 is 8. I can split that numerator apart so I can combine a like term. I have 1/4 plus 1/2 the cosine of 2x plus 1/8 plus 1/8 the cosine of 4x. And then from here, about the only other thing left to do is we can kind of combine these two constant terms. We have 1/4 plus 1/8, getting a common denominator. That'll end up giving us 3/8 plus 1/2 the cosine of 2x plus 1/8 the cosine of 4x. And now we've achieved our goal. This expression involves only trig functions that are being raised to the first power. The next set of formulas we're going to look at are the half angles formulas. For example, the sine of alpha divided by 2 is going to be equal to either the positive or the negative of 1 minus the cosine of alpha divided by 2, where the plus or minus symbol itself will be determined dependent upon the quadrant in which alpha over 2 resides in. The cosine of alpha divided by 2, that is going to be plus or minus the square root of 1 plus cosine of alpha divided by 2. And I think there's a mistake here in the notes. Excuse me, this should be the tangent of alpha over 2. Tangent of alpha over 2 should be either plus or minus the square root of 1 minus the cosine alpha divided by 1 plus cosine alpha. Let's take a look at example 5. We're asked to find the exact value of the cosine of 112.5 degrees. So we look at this, and it's probably going to be an odd angle when we first view it. We haven't calculated anything like a 112 angle before, let alone something that has a half degree to it. So when you see like a fraction of an angle like that, especially like a 0.5, you should probably think about the half angle identities. Here, if we think about 112.5, it turns out that that is exactly half of 225. And 225 degrees, that's an angle in quadrant 3, whose first quadrant angle would be 45 degrees from quadrant 1. So that's an angle that we would actually be able to know the exact value of. So here, the alpha is being played by the role of 225 degrees. Okay. So we're going to use the formula for the cosine of alpha over 2. Again, it's plus or minus the square root of 1 plus cosine alpha over 2. So this is going to be the square root of 1 plus the cosine of 225 degrees divided by 2. And we need to determine whether this is going to be a plus or a minus sign in front. Well, let's take a look at 112.5. From our All Students Take Calculus, 112.5 is more than 90, but it's less than 180. So this is an angle that's going to be in quadrant 2. And we know that in quadrant 2, the cosine should be negative there. So the sign that we need to attach to this radical should be a negative. So this is going to be the negative, the square root of 1 plus, for the cosine of 225, 225 degrees, that's an angle in quadrant 3. That's where the cosine is negative. Its first quadrant angle would be 45. We know that the cosine of 45 is square root of 2 over 2. So this value should be the negative square root of 2 over 2. This is the value. We just need to put it now in simplest terms. We have a complex fraction in that numerator. So let's go ahead and multiply to simplify this. I can multiply the main numerator and main denominator by 2 to get the following. This is the negative of the square root of, in the denominator 2 times 2 is 4. In the numerator I would be distributing the 2 through to get 2 minus the square root of 2. That simplifies the complex fraction. I can take the radical of the numerator and the denominator. This would be the square root of 2 minus the square root of 2, all divided by the square root of 4. And we know that the square root of 4 is 2. So we get negative the square root of 2 minus square root of 2, all divided by 2. And now that would be in simplest terms. This is the exact value of the cosine of 112.5 degrees.